Another important category of functions are piecewise functions. Right? These are used a lot, especially in calculus. Piecewise functions are just like they sound. They're functions made in pieces. Right? So the idea is that instead of having one rule for every x that goes into a function, you're going to have different rules depending on what values you want to put in. So as an example here, take a look. So what this is saying is that the function f of x, what does it equal? All right, what is the rule to tell me what to do with x? Well, the rule is do x squared if x is between -2 and 0, including -2, not 0. Otherwise, if x is between 0 and 7, including 0 but not including 7, I don't do x squared, I do -x minus 2. I only do the version of the function that corresponds to where my x is. So we're going to see when we try and evaluate this function that we have to find out where it is first before we apply a certain rule. Now, if the x isn't in one of these pieces, then the function doesn't address it at all. The function's not defined for that value. It's not in its domain. Okay, so again, you should only be evaluating the function once for a particular x value. You don't put it into different pieces. It should only go into one piece. For example, if I want f of -1, all right, I have to say, if I want to evaluate this, I have to go and look and say, oh, hey, where does -1 fall? Well, -1 is between -2 and 0. So -1 is in here. That means I use the x squared rule. So I would do -1 squared or get 1. Great. Okay, let me get rid of all that. Now we go back. I'm going to get rid of this too. If I want to do f of 3, I have to find out where is 3. 3 falls in here now. That means I do -x minus 2. So I do negative the 3 minus 2. That's -3 minus 2. That's -5. Notice I'm not plugging it into the other one as well, just the one where you find that value. All right, f of 0, say. All right, so where is 0? Oh, 0, the first interval goes up to, it doesn't include 0. Here we are, 0 is actually in here. That means this is the rule I'd be using. So -0 minus 2, so 0 minus 2 is -2. F of -4. All right, let's look at that. F of -4, where does -4 doesn't fit in any of these. That means this is not defined. This function is not defined for -4. It just doesn't address it at all, right? This is not saying that -4 couldn't be squared or couldn't be taken negative and subtracted 2. This just means that this function doesn't deal with -4. All right, what is the domain of f? Okay, so that usually meant looking at a function and deciding what was allowed in. Well, that's what we're going to do here, but what is allowed in is actually defined by the function. In fact, that's what we're talking about when we look at those values, those intervals there. This is actually giving us the domain. So all I have to do is actually put these pieces together. So the first one starts at -2 and includes -2. Then it goes up to almost 0, but the second one picks up at 0 and does include it, and goes up to but doesn't include 7. So I start at -2 and I go to 7, but I don't include 7. So this is a closed bracket, and this is an open parenthesis. All right, well, let's now sketch a graph of f. So how do we sketch a piecewise function? Well, what we're really going to do is we're going to sketch each piece. All right? So the way I like to do it is I'd like to get a graph going here. Get a set of axes. So I'm going to say 1, 2, 3, 4, 5. I'm going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And let me go 1, 2, 3, 4, 5, 6, 7, 8. And 1, 2, 3, 4. Okay, so there's my x, and here's my y. And what I want to do is I want to go back and I'm going to say, how about f of x equals x squared? What does that look like in general? And so what I might do is I might think about in general, what does that look like? Well, if I had that in general, that means 1 would give me 1 squared or 1, 2 would give me 4, -1 would give me 1, and -2 would give me 4. Okay, and that's where in general I would get a graph that looked like the one we were familiar with before, like this. Okay, but the only thing is I don't want that whole thing. I only want the portion of that graph corresponding to -2 to 0. So what I have to do is, now normally I would just erase parts of this, but I didn't want to do that. It's okay, I'll fix that. So I'm going to get rid of some of this, and I'm actually just going to do from -2 to 0. I just want that piece. So -2, including -2, so I'll darken it, and then I'm going to go and do that same piece I had to 0, but I don't want 0, so I leave it open. So that is the portion. So I'm talking about having this, but getting rid of all of that except for here to there. So that's really what I've done there. I've picked that out. All right, so now let me just give you the -2, and that's supposed to be at the 4 level there. All right, so it's supposed to line up. Okay, so now what about the other piece? Well, the other piece was, whoops, missed it, -x minus 2 from 0 to 7. Well, -x minus 2, that's just a line with a y-intercept of -2 and a slope of -1. So that would say -2 as a y-intercept, and then I'd keep doing a slope of -1, so down 1 over 1, 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 and going all the way, and we're going to go out to 7. So 1, 2, 3, 4, 5, 6, 7. All right, so when I plug in 7 into -x minus 2, that should give me -9. So 1, 2, 3, 4, 5, 6, 7, 8, 9. I missed that. 1, 2, 3, 4, 5, 6, 7, 8, 9. So that should be over there. Oh, except we don't include it. We were open there. So I'm actually just going to get that piece right there. It did include 0, so dark, fill that circle in. It didn't include 7, so that one's open. I want to make sure that looks open. Okay, so that would be the graph of the piecewise function. All right, now, usually we said when we have graphs, we could give the range. So we can do that here as well. So remember, the range is starting from negative infinity in y and going all the way up. So when we start in the very negative, when we come up, we only start to look at getting a value when we get around -9. So we start around -9. We don't get -9 because it's open there, but we get everything above it, and we keep getting values all the way up to, this was -2 here, up to -2, and we do get -2 because it's solid. But then we have a space. We have a space, like at -1, we'd never get that value. So we skip all that, so I'm going to do union. And then 0, we start about again, but not at 0, it's open there. And we keep getting values in here, up to getting 4, and we do get it because it's closed there. So there's the range of our function, which would have been difficult to do directly from the function itself. And that's how we can deal with piecewise functions.